Okay guys, today we'll do two sections, okay? Section 1.3 and section 1.4. I believe these sections, okay, from chapter 1, they're mostly review sections, okay? You have already took Math 136 college algebra before, right? Either here at Ivy Tech or at a different, university, okay? So these sections, these functions, they should look familiar to you guys, okay? All right, so section 1.3, new functions from old functions, okay? So these are our essential functions, okay? Essential functions. They're very basic functions. Okay, let's look at them one by one, okay? Yeah, one by one. So linear models, we call them linear functions, okay? They're defined by y equals mx plus b. You remember it? Okay. As an example, y equals 2x plus 3. This is a linear model. Do you remember the shape of this type of the function? Straight line, right? Straight line. Okay. 2 points, at least 2 points determine a line. Okay. So linear functions defined, in general, y equals mx plus b. With m is what? Slope of the line, and b is what? Y-intercept, right? Y-intercept. So polynomial, okay, polynomial. P of x is defined by an x to the nth power plus an minus 1 times x to the n minus 1's power, blah, blah, all the way to a1 times x plus a0, okay? So polynomials, okay, are defined like this. The powers, okay, the powers where exponent of x are all what? So these are what? All positive integers, or what? 0, okay? Yeah. So the exponent of x, they're all positive integers, or 0, okay? When the exponent equals 0, x with 0 is 1. So that's how we get the constant part, right? Constant term, okay? Power functions, f of x equals x to the 8th power. So for example, f of x where y equals what? So for example, x to the cube. What type of function it is? It is a power function, right? Say y equals f of x equals x squared. Y equals f of x equals what? X to the 4th power, 5th power, 6th power, and so on. They are power functions, okay? Well here, when a equals n, okay? So n is what? Exponent. If the exponent is a positive integers, we have this type of the power functions, x to the 1st power, x to the square, x to the cube, and x to the 4th power, and so on. However, okay, this a, which is exponent, could be what? When a is a positive, n is positive integer, 1 over n is what? It is a fraction, right? So what type of the power function can we get? See the example, x to the, when a equals 1/3, what type of function is this? Root functions, right? Radical functions, right? See the example, x equals x to the 1/3 power. It is the same thing as cube root of x. How about y equals x to the 1/2 power? That's square root of x, okay? Yeah, so this, these are also power functions, okay? But this type of function is, okay, radical functions, okay? Radical expressions, okay? So when a equals -1, we have what? Y equals x to the what? -1's power. How can we compute the x with -1's power? What is the definition for negative exponent? It is defined by what? 1 over what? X, okay? Right, guys? Okay, so these are the power functions, okay, when a are positive. See, all of these a's, for the first two cases, a are positive numbers, okay? A is positive integer, 1 over n is also positive fractions, positive number, okay? However, this case is when a equals -1, we have what? The reciprocal function y equals 1 over x. Well, actually, guys, this f of x equals x to the 8th power, okay? This a could be what? Could also be negative fractions, okay? Could be, negative fractions. So for example, y equals what? I'm going to write it here, okay? What is y equals x to the 1/2 power? Can we simplify this expression? See, this exponent is a negative fraction. How? We can rewrite it as what? 1 over x to the what? 1/2, right? What is x to the 1/2? Square root of x, okay? So all of these type of the function, when y equals x to the 8th power, okay, 8th power, they're called power functions, okay? The a could be positive integers, could be negative integers, could be positive fractions, could be negative fractions, okay? And a, see, in particular, when a equals -1, this integer, we get a reciprocal function, okay? So here, x to the 8th power gives us power functions. You just know it, okay? You just know it, okay? Why? Because later I'll let you compare the power function, the form of power function, and what? Exponential function. They look very similar, okay? We'll talk about this very soon, okay? But they're different, okay? They're different. So another type of the essential function is called a rational functions, okay? Rational function f of x equals p of x over q of x, where p and q are what? Polynomials, okay? So we know polynomial functions. So what kind of function is defined to be rational function? If we have a division of two polynomials, that gives us what? Rational functions, okay? Well, trig functions. There are 6 basic trig functions. Do you still remember the 6 basic functions? Trig functions: sine, cosine, tangent, cotangent, and also what? Secant, and also what? Cosecant. Okay? So these are the 6 basic trig functions. Okay. Well, here in this section, in this chapter, okay, assume from section 1.4, we'll start to learn exponential functions. Section 1.5, we'll learn logarithm functions. These two are very important functions as well. Okay, so exponential function f of x equals a to the x power. Okay, where this a we call it is what? The base of the exponential function, right? And x we call it is what? Either index or exponent or whatever you call it, okay? And for the base a, it must be a positive real number but cannot be what? 1, okay? So in section 1.4, which is our today's material, okay, we'll learn that a is positive but not equals 1, okay? So on that real number line, okay, for a, if a is positive than greater than 0 but not equals 1, actually we'll have 2 intervals. One is when a is what? Between 0 to 1, and then the other interval is when a is between 1 to what? Infinity. So that's why for the exponential function there are 2 cases. One case is when the base a is greater than 1. The second case is when the base a is between what? 0 and 1. We'll talk about this in section 1.4, okay? Because this is section 1.4. Today's material we'll talk about that. And then logarithm function is an inverse function of exponential function. We'll talk about this type of function in section 1.5, which is, probably next week. Okay, we'll talk about logarithm functions, okay? And then f of x is defined by log of x to base a. Here, same thing. A is greater than 0, but a cannot be 1, okay? So that means for logarithm function, we'll also have 2 cases. One case is when the base a is greater than 1. The other case is when the base a is between 0 and 1, okay? Yeah, so these are our essential functions we learned before. These are the old functions we learned before, okay? I assume you have already learned all of these functions. You've seen them before, right? Now guys, as we just talked about, do you see the difference between the power function and the exponential function? They look very similar, right? What's the difference? What's the difference between these 2 functions from the expression?
In the former case, the variant is the base, and in the latter case, invariant is the exponent.
Yeah, very good. Power function, you see the base is what? It's not a constant a. The base is what? Variable x. And then the exponent is what? It's a constant a. Okay, so this is a power function. See the example. Yeah, these are the power function, x to the something, or x to the something, or x to something, okay? However, for the exponential function, f of x equals what? A to the x power. How about the base? The base is a constant a. How about the exponent? The exponent is what? Variable x, okay? So, in section 1.4, we'll learn how to sketch the graph for f of x equals a to the x power, okay? So that's totally different from the power function. It's different, okay? Now, can you see that? X to the x power, this is what? A to the x power, but they're different, okay? So if we talk about these two functions separately, you may not be able to see the difference. But if we put these two types of the function together, you see the difference? You should see the difference, right? Okay, so these are just a review, okay? These are just a review. Now, let's look at the transformations, okay? The transformations. For the transformations, guys, you also learned this before. I assume you learned this before in college algebra, okay? I teach college algebra, okay? So, there are three types of the transformations. The first type is called what? Shift, right? Shift. So type 1 transformation is called shift, okay? Do you still remember the second and the third type of the transformation? What is the second type? What? Stretching and what?
Compressing.
Yeah. Yes. It's called stretching and shrinking. Well, I don't like this word shrinking, so it's called compressing, right? I would say compressing is the same thing as compressing. Well, compression, right? Stretch and compressing. Okay, stretching and compressing. This is a type 2, okay? Type 2 transformation. How about the third type, guys? Reflections, okay? Yeah, this is type 2, sorry. And the type 3. Okay, I assume you have already learned this before, so I'll just go over these three types and then we start to work on questions, okay, work on questions. So, let's go back to the type 1 type of the transformation, shift, okay, shift. Okay, here I'm going to ask a volunteer to read these 1, 2, 3, 4 sub-cases of the type 1 transformation, the shift, okay? Who want to read? I have the attendance sheet with me on paper, so it's the time for me to start to know you guys, okay? So I call your name, okay, and then you're gonna read for us, okay? So in the meantime, I know who you are, okay? So let's start from John. Yep.
Suppose.
Yeah.
Suppose C is greater than 0 to obtain the graph of y equals f of x plus c. Shift the graph of y equals f of x and distance c upwards units upward. Y equals f of x minus c. Shift the graph of y equals f of x a distance c units downward. Y equals f of x minus c. Shift the graph of y equals f of x a distance c units to the right. Y equals f of x plus c. Shift the graph of y equals f of x a distance c units to the right.
Very good, thanks, okay? So these 4 sub-cases, okay? So this is a briefly picture, okay? So for example, this is our original function, okay? Or standard function, or basic function, or original one, whatever you call it, okay? It is y equals f of x. The graph of y equals f of x plus c means we add c unit to the function y equals f of x. Means we shifted this original function up for how many units? C unit. If c is positive, guys, c is positive, okay? And then, of course, shift down, we have y equals f of x minus c. I hope you guys can see this, okay? So this is the up and down shift. How about left and right? If we replace the x by x minus c, the graph goes left or right? Right. Why?
Because
remember?
X has to be C in order to find your y-intercept.
S has to be C.
So it would be C minus C, 0,
Yeah.
and you have the y-intercept.
Yeah. Okay, very good. Okay, I don't know whether did you get what he said? Yeah. Okay. So the explanations are in the textbook. You can go and go to the search the textbook and find out. Okay. Here I need you guys to memorize. If we have x minus a constant replaced by x, okay, replace x, we shift the original function to the right. Remember it. And if we replace the y equals f of x, the x by x plus c, we go left. Okay, we go left. Just remember that. Okay, remember that. If you want to figure out why, the textbook tells that already. Okay. Okay, so this is type 1. Okay, shifting. Can we go on? Stretching and compressing. Okay. So there are 4 subcases. Stretch and compress. Okay, 4 cases. I'm going to ask another volunteer read this 4 subcases for us. Okay. So let me see whose turn. Dylan?
Suppose C is greater than 1. To obtain the graph of y equals C f of x, stretch the graph of y equals f of x vertically by a factor of c. Y equals 1 over c f of x, shrink the graph of y equals f of x vertically by a factor of c. Y equals f c times x, f of c times x, shrink the graph of y equals f of x horizontally by a factor of c. And y equals f of 1 over c times x, stretch the graph of y equals f of x horizontally by a factor of c.
Very good, thanks. Okay. Well, here c is greater than 1. Okay, c is greater than 1 means c could be 2, could be 3. It is a number greater than 1. Okay. So for vertically, stretching and compressing, or shrink, whatever they call it. Okay. So if we have c, this factor c multiplied by the f of x, c is greater than 1. Okay. Then we say, okay, this new function comes from stretching the original function vertically by a factor of c. Okay. However, if we have y equals 1 over c, because c is greater than 1, how about 1 over c? Well, c is a number less than 1, right? Because c is greater than 1. So if we have a factor 1 over c which is less than 1 multiplied by f of x, okay, so we say, we're going to shrink the original function vertically by a factor of c. We'll compress vertically. Horizontally, guys, it's kind of slightly different from the vertically compressing and shrinking. Okay, yeah, we're compressing because when we replace the x by c times x, okay, c is greater than 1. Okay, so for the vertically stretch and the shrink, okay, if c is greater than 1, we vertically stretch. However, horizontally, guys, okay, horizontally, if we replace x by c times x, c is greater than 1, horizontally we have to do what? Compress. Okay, compress. Okay, say for example, okay, guys, I'll give you an example. Y equals, say for example, x squared. Okay, this is what? The graph of y equals square is a parabola, right? Guys, everybody know that. Okay, so negative 1, 1, 0. This is just a example. Okay, example. Then if I want you guys to graph y equals 2 times x parentheses square, how to graph this new function? See, we replace x by c times x, with c is what? Greater than 1. So how to sketch this function y equals 2x parentheses square? Let's still find key point, guys, right? Key point. Well, x equals 0, y equals what? 0, right? So 0, 0. Alright, now I'm asking you guys, for what values of x that we're going to choose will make the y value equals 1? Can we choose x equals 1? Positive 1?
Probably it's 4.
Yeah, that will give us y equals 4. Now, I mean, in order to get a y equals 1, this 2x must be equals what? 1, right? Or negative 1 to make the square equals 1, right? So if 2x equals 1, x equals what? 1/2. So that means when we choose x equals 1/2, guys, 2 times 1/2 is 1. That gives us y equals what? 1. Guys, do you see that? When x equals 1/2, y equals 1. Similarly, when x equals what? Negative 1/2. 2 times negative 1/2 gives us negative 1. Negative 1 squared is what? Positive 1. So, with the 3 key points, negative 1/2, 1, 0, 0, and what? 1/2 and 1. So this is a graph for what? Y equals 2x parentheses square. Right, guys? Now, my point is, horizontally, do you think this graph comes from stretching the original graph horizontally or by compress or shrinking? Compress or shrinking. Shrink, right? See? This is an example for what? Oh, if c is greater than 1, which is 2 in this example, okay, the new graph comes from what? Shrink or compress the original function horizontally by a factor of what? 2 in this example. You guys see that? Because it's hard to understand, okay? Oh, if we multiply c is greater than 1, vertically we have to stretch, right? Stretch, c is greater than 1, right? But horizontally, if we replace x by c times x, c is greater than 1, horizontally we have to what? Shrink or compress. You guys see that? Okay. Well, if we replace x by 1 over c, c is greater than 1, so 1 over c is less than 1, right? Less than 1, okay? So, horizontally we stretch the original graph by a factor of what? c, okay? Okay, so these are the compressing and then stretching. Any question from these subcases? No? Okay. So last case, last type, reflection. Okay, reflecting. Okay, I'm going to ask another volunteer read these 2 subcases for us. Okay. So let me see who's turn. Sunny? Sunny?
Yeah.
Can you read these 2 lines for us, please?
All right, y equals negative f of x. Reflect the graph of y equals fx about the x-axis, and y equals f negative x. Reflect the graph of y equals f of x about the y-axis.
Very good, thanks. Okay, so if we multiply a negative 1 to the original function f of x, that means for whatever x we choose, the y value becomes what? A negative, well, become an opposite sign, right, from the previous function. Okay, so guys, let's look at the picture here. If this is a original function, y equals f of x, and then what will be the graph for the y equals negative f of x? Yeah, for the same x value that we choose, the y value becomes negative, right? It becomes different, right? You know, opposite sign. So that means if we multiply a negative 1 in front of the function f of x, we reflect the original graph about which axis, guys? About x-axis, okay? Well, if we replace the x, original function, the x, by negative times x, and then we will reflect the original graph about which axis? Y, okay? So this is f of negative x. Remember these 2 subcases, okay? Alright, so far we're done for reviewing for the transformations, okay? Now let's see whether we're able to solve specific problems, okay? So let's look at this example, okay? I'm going to ask some of you guys read the questions. So this is a way that we interact and then you guys participate, okay, in the class. Grant, can you read this example for us?
Graph the function by hand, not by plotting points, but by starting with the graph of one of the standard functions and then applying the appropriate transformations. A, y equals x squared minus 4x plus 5.
Very good, thanks. Graph this function by hand, not by plotting points. By plotting points is easy, right? You choose those x values, you compute the y values, you find key points in your graph. No, we're not going to use plotting points, no. However, by transformation, how can we graph this function? Do you have any clue about this? To graph y equals x squared minus 4x plus 5?
Why don't we move 5 units up?
Move what function 5 units up? Move this function y equals x squared minus 5x 5 units up.
That's what it says, plus 5, right?
Yeah, plus 5. But do you know how to graph y equals x squared minus 4x?
No.
No, right? But do we know what standard function can you think of from this given function?
Parabola.
Parabola, right? Parabola, yes, it's a polynomial, right? So the very standard, very basic function, we can think of from this complicated one is y equals x squared. Do you know how to graph y equals x squared? Everybody know it's a parabola. We just did it, right? So just pass through the 3 key point. If we graph it, okay, let's graph it very briefly. Everybody know how to graph y equals x squared, right? So the graph looks like this. Okay, so y equals x squared is our standard function. Okay, so this is our standard function. Standard function. Okay. Well, the thing is, what kind of transformation can we make? Can we do to start from the standard function and we get this y equals x squared minus 4x plus 5? We have to do some simplifications, right? Simplifications. X squared minus 4x.
If that's what we're doing, can we complete the square?
Complete the square. This is Dakota's idea. Agree with him? Complete the square. How to complete the square? X squared minus 4x. Okay, what is complete the square? Okay, guys. If we have x squared minus 2xy or plus 2xy, whatever, okay, then plus y squared, it will give us what? X minus y squared. Remember this formula before? This is a complete square formula, right? Or if this is positive, we're going to have a parenthesis x plus y squared, right? So these are the formula we learned before. It's called complete square formula, right? Okay, good. For complete square formula, in order to finish up the complete the square, we need how many terms, guys? 3 terms to finish the square, right? To get this. So far, we only have x squared minus 4x. There are only 2 terms. Can you think about it and then get this y, figure out the y, and then the y squared? X squared minus 4 times x. What?
So what we can do is negative 4x matches a negative 2xy. So we can say somehow negative 2xy is equal to negative 4x. I'm going step by step here.
Okay.
And then we can solve for y.
Okay, so Dakota suggests we do x minus 2 squared, right? Is that what we suggest? You do a...
That's where we end up, but yeah. Sure.
So, x squared minus 4x plus what? 4. This is a reverse thinking, okay? But I would say that...
Oh, that's not what it said.
That's really what I said.
So what I said is saying negative 4x, so write a new equation, is equal to negative 2xy, and then you solve for y.
Okay. So, Dakota said, we want to figure out the y, so we can get y squared here, right?
Yes.
We want the negative 4x equals negative 2xy. And from here, we get what? The y, so for y. So how, guys? How about if we divide by negative 2x from both sides? Right? So negative 4x divided by negative 2x give us what? 2. So what is our y in this problem? It is 2. Or, guys, we can rewrite like this, okay? So, yeah, this is a repeating step, okay? It is going to be x squared minus 2 times by x times by what? How about this? It's the same thing as, x squared minus 2 times x. It should be negative 4x, but now we have a negative 2x, right? So what is y? 2?
Oh, that's right. That's what I thought from the beginning.
Yeah, you got it right.
Why didn't you do the square square?
Well,
Oh, I see.
Why didn't you put the square?
because we're gonna have you'll see, we'll have a y equals x minus 2 square, and then this is like, by using transformation, we can get from y equals x squared to a y equals x minus 2 square. Because this is the transformation, the shifting, the type 1.
Right.
Yeah, you probably missed that part, right? So, but yeah, so we'll go over this part very, very soon, okay? So, when we figure out y equals 2, so y is 2, so y squared is 2 squared, right? However, this is x squared minus 4x plus 4. In order to balance with the original function, we need to add 1, right?
Yeah, why are we adding 1? Because we have to balance the function.
Because we originally had x squared minus 4x plus 5. Now, we have x squared minus 4x plus 4. That's not enough, right? We have to make sure this line equals that line, right?
Okay, I see.
So, this is 4 plus 1 and give us the 5. And then this is still negative 4x, okay? And we can tell, I don't have a red pen, I don't have a red pen. Okay, that's fine, let me
I
focus.
have a multicolored pen with color.
Yeah, can you please lend me your color pen? I just want everybody's, next time I should bring a red pen with me. I usually do, but, okay, so 2xy, y squared, right? Thanks. Okay, now let's see what we get here. Some of you guys may still be confused about, oh, what am I doing right now? Why are we doing this? So, these three terms give us what? X minus 2 squared. This is what? Plus 1, right? So, from the standard function, our new function is, our function is what? Y equals x minus 2 squared plus 1. Now we are going to use what? Transformation to get the graph of this function. Okay? So, from this function, what's going to be our next step? You see? What's the difference between, why it is shaking? Hold on. I hope it will move. Okay. So, from y equals x squared, we want to get this function. We're going to do it step by step. How about we transform from y equals x squared to y equals x minus 2 squared? What kind of transformation should we do about it? This is what? Y equals f of x. This is y equals what?
So shift to the
F
right.
of x minus 2, right? Shifting
To the right.
Right.
for how many units?
For 2 units. Yeah.
Very good. Shift right for 2 units. Alright, so that means, okay, so we're going to shift this graph, okay, a standard function, this is a standard function. We're going to shift it to the right for 2 units, okay? So, originally we have a 0, 0. I just do not want this thing is, it's shaking. Hold on 1 second. Oh, it's because it's not heavy enough. Okay, I'm just now, it fall. Focus. There we go, no shaking. Okay, so to the right for 2 units, let's graph it briefly. Okay, so this is what? This is a graph of what? This is a graph of y equals x minus 2 squared, right? But we're not done yet, right? We want to have this final function, right? So we want to get y equals x minus 2 squared plus 1. So from this intermediate function to this final function, what kind of transformation should we
Shift up 1.
shift up for what? 1 unit, okay? So shift up for 1 unit, okay? So from this graph, we're going to shift it up for 1 unit. So briefly, okay? So it says just use transformation and graph it briefly. Okay, so this is our what? Final graph, right?
Yeah.
Final graph. And this is for what? It is for y equals x minus 2 squared plus what? 1. You guys? Simon, you have question? No?
I did have a question, but I realized why I was wrong.
Okay.
Because it looks like, at first it looks like it is use of shift up and score, I guess.
Yes, for this problem, we may shift up at first, and then we shift to the right for 2. It doesn't matter.
I think he's talking about at the very beginning.
Well, yeah.
X squared minus 4x plus 5.
But the thing is, understand that you want to shift this function up, but okay, you want to shift it up for 5 units directly, right? But the thing is, you have to figure out how to graph y equals x squared minus 4x without plotting points. So that's the reason we have to complete the square, so we can do from the very standard function y equals x squared. Everybody know how to do it. You know how to graph it. Then we start from there. If you want to shift this function up for 5 units from this, you have to figure that out. Figure out how to graph this function. But it's not easy. I mean, I cannot say it's impossible, but it's really hard to figure out, right? To graph this.
One more thing, on the test, because there's no way I can remember all these formulas. Are you going to give us a formula sheet?
I have to think about it. What did I do for my previous Calc 1 classes? For my Calc 3 class, I remembered I let students prepare their own formula sheet. I check. No notes, it's not notes, not a problem. But for Calc 1, let me remember that, okay, after class, because my mind is focused on the lecturing. I'll let you know, okay? Because I can't remember. The last time I taught Calc 1 was like 3 years ago, I can't remember. Yeah, okay. So I will let you know, definitely, okay? I will. This is recording video. I will let you know, okay? Okay, any question about this problem? No? Okay. All right, so let's move on to the next page. Where's the next page? Next page is here. Okay, it is here. Okay. All right. So also graph y equals sin of 1/2 x without plotting points, just by transformation. So can you come up with a standard function from this function? What is standard function? Can you think of?
Son of x.
Sin of x, right? So y equals sin of x is the standard function. Okay, and do you know how to graph y equals sin of x? You still remember that? Okay, if you forget, that's fine. We can review that, okay? Looks like a wave, right? Horizontally wave, right?
With an origin of 1.
Yes. Origin 0, 0.
Or 0.
Yeah, okay, we have what? Sin the 1/2, pi over 2, 1, right? Remember? Okay. 1, negative 1. This is a point, pi half, 1. And then when x equals pi, we go back to 0 again, right? Y equals 0. This is half of a circle, full circle. And then when x equals what? 3 pi over 2, y equals negative 1, right? This is this key point, and then when x equals 2 pi, y goes back to 0. Remember this? This is a full circle for sin of x. Of course, this is just one circle, okay? But for sin function, what is the domain for sin function? All real numbers, right? So it's just repeating these full circles to the right and, extending to the right and left. Okay, I'm just going to graph it very briefly. Oh, my graph doesn't look very well, but okay. So this is y equals what? Sin of x, the standard one, right? But the main function we have is y equals sin of what? 1/2 x. Now, my question is, from standard function to this function, what kind of transformation can we make?
Stretch the graph horizontally by c,
Stretch or?
or it says 1/c.
Yeah, 1/c. Yes, you're right. So if we go back, it says, okay, 1/c, we have to stretch the original function horizontally by a factor of c, right? So from here to here, we're going to horizontally stretch by a what? By a factor of 2. That means we have to stretch it double, right? Like doubly stretching it. So that means, guys, if originally each full circle is, every 2 pi is a full circle. Now when we stretch it for by a factor of 2, what is our full circle right now? Double of the original,
So it would be
intervals.
0, 0 to pi over 0 and 1. Or pi would be pi over 1. I think.
This is one circle, right? Repeating, it's repeated and repeated. So 0 to 2 pi, well, every 2 pi is a full circle. If we want to horizontal stretch it by a factor of 2, that means now the new circle should be from 0 to what? In x direction, it should be from 0 to 4 pi.
Right, I know, but I was just saying the top part should be at pi, the highest point.
The highest point is 1, right?
Yeah.
Well, I'm adding all the x value, where x over 2, I mean, 1 pi over 2.
Pi over 2 is for the x-axis, and then this 1 is here, right?
Right.
I should write this coordinate here for this point. That makes sense, right? Yeah, okay. And this is for this point, right? It is for this point, for this point. But you know now the full circle is 4 pi, right? Also, Graham, can I borrow your color pen, please? Either red or blue, whatever. Okay. New circle is going to be from 0 to 4 pi. So, guys, we're going to have the graph looks like this. And then this is what? This is 3 pi. This is 4 pi. Oh, okay, so this is one circle. You guys agree with me? Horizontally stretched by a factor of 2? Okay, one circle, of course, you're gonna repeat it, okay, extend it to the right and to the left. Okay, all right. Okay, thank you.
If you want to hold on for the rest of the lecture, I have spares.
You do?
Yes.
Okay.
You just have to.
Yeah, okay, thanks. So that's good for this problem, guys, the transformation problem? Okay, in class, I'll just give you some examples. I would prefer that you practice your homework assignments after class, okay? Okay, so these are the transformations. We're not done for section 1.3 yet. We have the last type of the,
Just give her this one.
That's right.
Give her this one again.
the material from section 1.3. It's called combination of functions, okay?
Actually, give her that pen, and she can have it, and then you can send hers back.
Oh, sorry. I thought I had a spare pen. It's fallen through the hole in the bottom of my backpack, but he said this is a red pen.
Oh, okay.
I'm so sorry for
That's fine, that's fine. Can you fix that here? Okay.
Sure.
I have red pens, many red pens in my office. I just need to grab one next time.
I'm
I
so
will turn this
sorry.
once the class is over. Okay, thanks. Okay, combination of functions. Okay, so these are are easy. Okay, the sum of the two functions equals sum of subtraction, multiplication, and division. We're not going to talk about these by using a lot of time. Well, here I want to emphasize on what? Composite functions. Have you heard about composite functions? Okay, so f composite g. Well, this circle is not on top. It's just in between, okay? So when I type it, it looks like, the circle is on the top, but it's not. F composite g is defined to be f composite g of x equals what? G of x. F of what? G of x. Because g is more closer to x, okay? So we call g of x, this function is what? Inner function, okay? And then the f, this function is more further away from x, variable x, so we call it is a outer function. Okay, yeah, the name doesn't matter, okay? But you know that when we have a composite of functions, f composite of x, okay? We always deal with a function which is the function which is more closer to x. So we do g of x first, and then we consider f of the g of x. Okay. Similarly, for three layers of composite functions, f composite g composite h, it is defined by f composite g composite h of x Which function is more closer to x? H, okay. So we consider h of x first. It is called an inner function, okay? And g is kind of in the middle. We call this middle. I call it the middle. I don't know what textbook is called it. And then the f is more farther away. We call it what? Outer function, okay? So if you encounter the question to let your computer, f composite g composite h of x, how to simplify it? You do it this way, f of g of h of x. And then we always start from the inner ones and the outer layers, one layer by layer, okay? All right, guys, now let's practice. Find the functions, composite functions. Yeah, well, looks ugly, okay? F of x is this, defined like this. G of x is defined by x plus 1 over x plus 2, okay? All right, I'm going to lead you to do two of them, C and D together, and I will give you time to do A and B by yourself in group, okay? So, C, question C. Find f, composite f, of variable x. F composite f of x. According to the definition of the composite function, which function is the inner one? F. So f of x. Right? So how to understand f of x? So it's going to be f of x means now these x will all becomes what? F of x, right? So we know f of x equals x plus 1 over x. Each of these positions now becomes what? F of x itself. So what is f of x? Let me write it this way. What is f of x, guys? X plus 1 over x, right? Then what is f of x plus 1 over x? Replace these x by what? X plus 1 over x. That makes sense, right?
Yeah.
So this x becomes x plus 1 over x. 1 over this x is what? X plus 1 over x, right?
It's messy? Yes.
This is messy. Can we simplify it a little bit? We don't have to simplify it that far, but we can do something, right? So x can be written by x over 1, right? And these two, x over 1. So how to combine these two terms, can we?
It just be x, right?
Well, y is the denominator, x is the denominator. How to combine them? Common denominator, right? What is x? What is that?
It's an x, right?
X. So we multiply x to the top, give us x squared, divided by 1 times x is x. It's 1 over x. These are the first two terms, guys, right? 1 over. Same thing here. Same thing here. X squared over x plus 1 over x equals, these two can be together, x squared plus 1 over x, and then 1 over what? X squared plus 1 over x, right?
But since it's reciprocal, you can just
Flip it, okay? So we're gonna do one more step. X squared plus 1 over x plus x over what? X squared plus 1. Well, you may keep on doing that to combine these two terms, okay? Or you may choose to leave this answer here. You don't have to keep on doing that, okay? Because if you combine them, you have to find the least common denominator. It will make, everything into one fraction, but there are some other calculations, okay? You can keep on doing that, okay? But I consider this is already good.
So, like on the test, if we got that far, that would be okay.
That's fine, okay? Well, if you're not sure during the exam, let me know. Because all of the exam will be proctored exam in class. So if you're not sure for should you keep on doing the problem or should you can stop there. If you're not sure, let me know during the exam. I will let you know, oh, you're good, or you keep on doing it. Yeah.
can you explain to me how you cancel the x to the bottom of that fraction over there?
We're not cancel this x, right? We flip, because this is 1 over, right?
Alright,
See the example. What is 1 over 2/5? It equals 5 over 2, right?
right.
Flip. So 1 over x squared plus 1 over x, we flip this x up, that gives us the x, and then we have x squared plus 1 left on the bottom, right? Everybody? Ooh, this is messy, okay? So how about g of g? Oh, g of g is even messy, okay? I have to think about whether to let you guys do the a and b. Probably I will just give you the answer, but let's see, okay? Whether the d is time consuming or not. What is g composite g of x? So we know by definition it's g of what? X, right? g of x. What is g of x? The inner one? X plus 1 over x plus 2, right? Right guys? G of x is x plus 1 over x plus 1. 2, sorry. I said something wrong. How about g of this thing? G of this thing means we're going to replace every x in g by what? X plus 1 over x plus 2, right? Agree with that? Okay, so it becomes, this x becomes x plus 1 over x plus 2 plus 1, and then this x is same thing, okay? X plus 1 over x plus 2 plus what? 2. Whew. Actually, this is the hard part, because this is tricky. Simon, question?
Trying to let it go. Get the replacing with the function.
You get it, right? Because, see the inner function, you write it down specifically, and the outer function, you simplify. You see, it's still we treat the inner one first, and then we do it.
Yeah, I understand that.
Yeah, but, okay. All right, now, how can we simplify it? Yes, there must be a way we can simplify that, right? Because on the top, there are two fractions, x plus 1 over x plus 2 plus 1. Can we combine these two? See, 1 can be considered to be what? X, what is a common, 1 over 1, right? This is 1 over 1.
2 over x plus 2.
Yes, x plus 2, you're right. And see, this is 2 over 1, right? So we can get x plus 1 over x plus 2 plus a twice of x plus 2 over what? X plus 2, right? What do you think? Okay, and then let's do it over here. So on the top, same denominator, right? X plus 2. So we're going to add on the numerator, right? X plus 1, x plus 2 give us what? 2x plus 3. And then these two add together give us x plus 2 on the bottom. Careful here. X plus 2x, x give us that, okay, distribution. X plus 2x give us what? 3x. 1 plus what? 4 give us 5. Okay? And now both top and the bottom, they have the same denominator, right? Or you can say, let this fraction multiply this fraction, flip upside and down. But you can also cancel out the x plus 2. So eventually answer is what? 2x plus 3 over what? 3x plus 5. What do you think? Okay, right? It's challenging, but it's okay. Can you please try question A and B by yourself? What time is it now? It's already 4:30. We'll have another 45 minutes, right? So, I would leave this question A and B later, okay? If we have time in class, we do it, okay? But I don't have an answer for that. Yeah. I'm gonna see whether I can get an answer quickly. So yeah, give me 2 minutes, okay? I'll give you the answer, okay? Then you try it by yourself later, okay? I don't think we have time in class. We have another section today, okay? So let me try this, okay? In the meantime, you can also practice that, but I'm gonna do it quickly, okay? G of x, f of g of x. Oh, okay. So this is not very hard, okay? Eventually you will get x plus 1 over x plus 2 plus x plus 2 over x plus 1. Try this after class. This is the answer for A, okay? Answer for B may be complicated. G of f of x. Okay, so this one is okay. Answer is of course this you can complete square this. This is x plus 1 parentheses square. Either way, okay.
For A, that's where you want us to stop, you don't want us to find it.
No, if you want to keep on doing that, that's fine. You will get a common denominator, and then you will do x plus 1 square plus x2 plus 2 square. Yes, you can keep on doing that. But I think this is okay. Well, you also have to check your, I don't know, for the Weibull sign, sometimes they require you to type in a certain form of the answer. You have to pay attention, okay? So sometimes you get a correct answer, but you don't type it in correctly. The system may mark you wrong. If you encounter that type of problem, you think you get it correct, but as the system does not accept it, let me know, okay? Let me know. I will help you to get a correct answer. Yeah, okay. But here, I don't think, the simplification is that, yeah.
Right, because I did all.
Alright, so this is section 1.3. Any questions from section 1.3? No?